Hello. So we are back again with one more lecture session on infinite series. In the last two sessions, we had been discussing tests of convergence for positive series. So far, we have seen two such tests of convergence, namely the comparison test and the D'Alembert's ratio test. Now, today's session, we will see the third one, Cauchy's root test. So let us see what does it say. So let sigma un be a series of positive terms such that limit un to the power 1 by n tends to infinity equal to L. Then the series is convergent if L is less than 1, divergent if L is greater than 1, and the test fails if L is equal to 1. So what are we doing in this test? What we have to do is, we can see over here that we have to take the nth root of your nth term and then take the limit as n tends to infinity. And our decision now depends on this value of the limit L. So if this limit is less than 1, it is convergent, greater than 1, it's divergent, and if it's equal to 1, we cannot conclude anything from this test. So the decision you can see, and you might remember that it's very similar as you had seen earlier in the D'Alembert's ratio test. However, in the D'Alembert's ratio test, we were taking the ratio of two consecutive terms of the sequence un plus 1 to un, and here we are taking the nth root of the nth member of the sequence. So let us now take up examples for the root test. So the first one here is examine the convergence of the series 1 by 3 plus 2 by 5 whole square plus 3 by 7 whole cube plus 4 by 9 whole to the power 4 and so on. So to examine this series, first we need to write down the nth term of the series or un and see that the un now can be written as n by 2n plus 1 to the power n. Why? You can see here, say this is our fourth term, you have 4. So the nth term is n to the power 4, so to the power n, and denominator is 9. When it's 4 over here, it's 9, so it's 2 times n plus 1. And now things are very easy actually over here. We take the nth root of this un. So if I take the nth root, we just get n by 2n plus 1. And now we have to evaluate this limit. So if we take n common from both the numerator and the denominator, we get limit n tends to infinity 1 by 2 plus 1 by n. So as n tends to infinity, obviously 1 by n tends to 0. So the limit is half. Definitely half is less than 1. So by Cauchy's root test, we can conclude that the given infinite series is convergent. Let us take up one more example. So test the convergence of the series 2 square by 1 square minus 2 by 1, the whole expression to the power minus 1. Next, 3 cube by 2 cube minus 3 by 2 whole to the power minus 2. Similarly, the third one, 4 to the power 4 by 3 to the power 4 minus 4 by 3, again the whole expression to the power minus 3, and it continues like this. So now once again, we need to write carefully the nth term or un. So see that the third term you have a to the power minus 3, second term you have a to the power minus 2. So nth term will have to the power minus n. And inside what we have, you see here, third term, it's 4 by 3. So nth term is n plus 1 to the by n to the power n plus 1 minus again n plus 1 by n. Okay. So now as we take the nth root of this term, of course this power now becomes minus 1. So we have limit n tends to infinity, this expression over here inside to the power minus 1. So minus 1 means basically all entire term is coming down. We have 1 by this expression. And now see that we can take n plus 1 by n common. So that only we have done. So taking this common, inside what we get, n plus 1 by n to the power n minus 1. And again, n plus 1 by n can be written as 1 plus 1 by n. So we have here in the denominator 1 plus 1 by n, and again 1 plus 1 by n to the power n minus 1. Now let us see what happens if we take the limit as n tends to infinity. Here in this term over here, 1 by n tends to 0. So this contributes only 1 as we take the limit. And what happens here inside? See that here we have 1 plus 1 by n to the power n. So this limit, we hope we remember that limit n tends to infinity. 1 plus 1 by n to the power n is a standard limit whose value is e. So that is what we have placed over here. So your final answer is 1 by e minus 1. And what is e? We remember the value of e. Of course, e is greater than 2. So e minus 1 is greater than 1. So then 1 by e minus 1 is less than 1. So therefore, once again, we have the conclusion that the given series is convergent. So with this, we will close today's session, and in the next session, we will see one more test of convergence, that will be Rabe's test. Thank you.